1st of December, I have handed over the charge of Head of Electronics and Electrical Communication Engineering to Professor Mrityunjay Chakraborty. So, yeah, that is just an update.
Yes, sir. So I actually mentioned that you have been serving as a head since last 6 years.
Yeah, right. Okay, thank you. So, in fact, this will be a very short presentation. In fact, I was expecting that the audience will be a mixed audience from various specializations. So the presentation that I have is mostly a popular lecture kind of thing, uh, indicating that where AI and machine learning as well as IoT can be applied in the farming or particularly precision farming operation to make the farming more productive and more efficient. So let me just share the slides. Yeah. Is the slide visible?
Yes, sir.
Okay.
Yes, sir.
So in fact, a similar such lecture, most of the slides are from that particular lecture around a few months ago in another program organized by Agricultural Engineering Department. So most of the slides that I have in this particular lecture are taken from that lecture. So let us see that what are the problems that we face or we are facing and we are going to face in coming years. The current population in the world is around 7.7 billion. And as per United Nations Food and Agriculture Organization report, this population is going to increase by 2 billion by the year 2050. So naturally, there will be an increase in demand of food by more than 50% of whatever we have at present. And there is an additional problem that as the population is going to increase, there will be increased demand on land for their habitation, for building the infrastructure, for their housing and all that. So as a result, the rate at which the population will increase, the increase in the agricultural land or farming land is not going to increase at the same rate. In fact, what has been predicted is only 4% additional land will come under cultivation by the year 2050. So you find that our increase of demand of food is 50%, whereas the additional land that will come under cultivation is only 4%. So there is a gap of 46%. So this is a major challenge. So naturally, to overcome this challenge, what we have to seek for or what we have to go for is more efficient farming, and you can have more efficient farming only by using the latest technological solutions. And while doing so, AI-powered solutions will enable the farmers to do more with less of resources. So use of this latest technology will improve the quality, and it will ensure the faster go-to market for crops. And when I'm saying that use of latest technology, it is not only for farming, it will also useful for marketing. In fact, the farmers will be able to predict that what will be demanded at how much at what point of time, so that they can plan their crops accordingly. And here comes the role of IoT as well as AI-based solutions, and this will help in precision farming to improve the yield. So this just sets the tune and tells us that what is the challenge ahead and how to mitigate those challenges. So our challenges are population growth. The climate is changing. In fact, the climate is becoming worse day by day. And at the same time, the loss of agricultural land due to urbanization. So these are the challenges that our future generation is going to face. So what we have to go for is we have to go for smart agriculture or smart farming, where we have to incorporate the latest technology incorporating Internet of Things. So what this Internet of Things are supposed to do is it is supposed to give you the data, collect the data from the farms regarding the farm condition, the land condition. It is supposed to collect the data regarding the crop health. Okay, so all this data, it is also supposed to collect the data regarding the weather, regarding climate. All these are the factors which affect the growth of crop. And then we have to feed this data, or we have to send this data to cloud for computing purpose, for decision making, where artificial intelligence and machine learning will come in a big way to help the farmers to plan their production. So there is a prediction that the market value of smart agriculture, and it is predicted that by the year 2025, the market value will reach around 15,344 million US dollars. So you find that there is huge potential and huge demand of the smart farming that is going to come. So here it is a small example. There is a company, Yanmar in Japan. They had built a smart greenhouse using IoT and artificial intelligence techniques. So this smart house, this incorporates wireless environmental sensors. It has cameras which tracks the plant growth. And this camera, or the video camera, that captures the growth of the plant continuously. So this video has to be analyzed, or is analyzed on cloud, to understand the various stages of crops growth process. So you find that through video processing techniques, through machine learning or data science techniques, you can understand that what is the level of growth that the plant has reached, and you can also estimate that what will be the requirement, the food requirement of the plants at that point of time. So using this, once the growth milestones are achieved, that is, the plant reaches a particular stage of growth, the water and nutrition proportion is adjusted, which is more suitable at that level of growth of the plant. So they receive the optimized mix of the nutrients, the water for their overall growth. And this is where your artificial intelligence or machine learning comes into picture. And this pattern of growth tracking and nutrient balancing, this helps to develop new methodologies for farming specific types of plants while maintaining resource conserving practices. So you find that I can have different types of plants. Different types of plants can have different requirements at different levels in their growth process. So all these resources, water, nutrients, they can be mixed appropriately. They can be applied in proper proportions at the stages where it is appropriately required, so that you can have more and more efficient use of resources for this purpose. So let us see that what are the factors that are involved in agriculture or involved in farming. Obviously, the factors of seed and soil, these are the primary. Water comes into picture, the nutrients, the pesticides, and of course the climate, which at some times becomes very, very challenging and it is unpredictable. So we have to make proper use of all these factors so that the farming is more efficient and we can feed the next generation in challenging times to come. So this is where your AI techniques or machine learning techniques supported by the Internet of Things will be very, very useful. So our challenges are weather forecasting. We have to monitor the soil conditions in terms of moisture, in terms of nutrients. You have to monitor the crop health so that you know that what is required at a particular stage of growth of the crop. Weed identification and treatment is obviously another challenge because weeds are not beneficial to the growth of the crop. Then comes the harvesting, and finally post-harvesting methods like marketing, because this is very, very important. I know, and all of you are aware the current agitation that is going all around the country, and this is because of the fear in marketing only. So this marketing is also a very, very important aspect which comes post-harvesting, because the farmers has to know that what is the market demand for what kind of product at what point of time, so that they can plan everything in advance. And at all these places, your IoT and data analysis, those are very, very important stages. So let us go a little bit into technology. So the first 2 points that I said are moisture and nutrient monitoring of the soil, which is very, very important for plant growth. So we have to go for proper moisture measurement, the proper moisture sensing of the farm, and for which different moisture sensors are available, right? Why do you need these moisture sensors? Because it is quite possible that you don't need to give equal amount of water over the entire field, because in some of the areas, the moisture content is sufficient for the growth of the plant, whereas in some other areas, the land may be dry, where you need to go for watering. So there comes the concept that you feed the people who are really hungry. Don't try to feed the people who are not hungry, because that leads to indigestion. The same applies to the growth of plant. The plants which does not need water, or the areas where you have sufficient amount of water present, if you pour water in that area, this is going to hamper the plant growth. It is not going to help the plant growth. But you try to water the area in the field where water is really required, the portion of the field which is dry. So for doing this, monitoring the moisture content of the field is very, very important. So this is a type of sensors using which you can monitor the moisture content of the field. And these sensors actually work on the principle of capacitance. So what it tries to measure is the water content, and this water content actually affects the dielectric permittivity of the medium. And as the dielectric permittivity changes, the capacitor, value of the capacitance between these two plates will also change. So what you try to measure is the value of this capacitance, and then if this sensor is properly calibrated, then from the value of the capacitor, you can estimate what is the moisture content in that particular area of the land. So this is what is a moisture content sensor. The moisture content or the water content of the land can also be sensed by thermal profiling, because in an area of the land, let us assume that the moisture is sufficient. So the trees or the plants, they collect water from the land through their roots, and the excess water they release in the environment in the form of vapors through pores in their leaves. And we all know from our school level science that this evaporation leads to a cooling effect. So the areas in the land where I have sufficient water or excess water, the plants in those areas will evaporate water through pores, which leads to a cooling effect, whereas in the areas where there is water scarcity, the pores will be closed and there will be no evaporation. As a result, temperature in those areas will increase. So we can also estimate what is the moisture content in different areas of the land by temperature profiling. And this can easily be done by using drones which are fitted with thermal cameras, because through thermal cameras we can estimate the temperature. So I can have temperature profiling of the land, and by analyzing the temperature profile, we can estimate what is the moisture content in which part of the land. So this is also possible. One way is, of course, using the moisture sensor. The other way, it can be done using temperature profiling of the land. The other most important part we have said is the soil nutrient sensor. Technically, this is known as NPK sensor because we know that nutrients, major components are nitrogen, phosphorus, and potassium, right? So this nutrient sensor is basically NPK sensor, and this is done in the optical room. So you find that for nitrogen, this table shows what is the absorption wavelength in nitrogen. So absorption band in nitrogen is 438 to 490 nanometer. In phosphorus, it is 528 to 579 nanometer, whereas in potassium, it is 605 to 650 nanometer. So the way this nutrient is monitored or measured is that we can have different types of light sources in the form of LEDs, which which emanate light in different wavelengths corresponding to these absorption bands. So these lights are reflected from the field, and if you have abundance of nitrogen content in the field, you find that because this comes in this absorption band of this particular wavelength, so if I import light in this particular wavelength, this light will be absorbed by the land. So when I try to sense what is the amount of reflected light, the amount of reflected light will be low. So I have these three different types of, say, light emitting diodes who are emitting light in these bands of wavelength, and these are detected by photodetectors. So from this detected light, you can estimate what is the amount of nitrogen, phosphorus, and potassium those are present in the land, which are nothing but the nutrients. And this data that you collect is can be processed using microcomputer, and you can find out what is the amount of nutrient, whether you have to add nutrients to the field or there is sufficient nutrient. So this is what is your soil nutrient sensor, right? The next important part is crop health monitoring. We have to find out that what is the stage of growth of the crop, and the best way to do this is by using the image or video processing techniques. So if we have large farmlands, we can capture the images by flying drones over the land. And the images that you get from these drones that can be processed later on the cloud, maybe on edge computer or on fog computer or in cloud computers, to find out whether the crop growth is proper or there is some problem in the crop growth. Okay. So these are different types of sensors that we can use, which are parts of IoTs. And here I show you some images which tells us that what is the kind of disease that the plant can have and what is their signature that is present within the image that can be captured. And as I said, that these images can be captured using by flying drones. So this is the one which shows rice or wheat infection by Magnapothe orizi. Okay, then this is a kind of disease which are known as stem rust. This is a kind of disease which is known as type rust. and so on. So you find that these are basically the signatures of different types of diseases which are present in the plant, that may be present in the plant. Okay. Similarly, these are some other diseases which can also be present in the plants. So through image processing or video processing techniques using machine learning or AI-based techniques, we can identify these diseases. And once the diseases are identified, you have to decide that what kind of pesticide that has to be sprayed and in what amount. Again, for spraying these pesticides in proper amount, again, amount is very, very important because uh, if you use excess of pesticide, it is not only wastage of pesticide, but the example that I just said, that it may lead to indigestion, right? So that may not be good for the plant's growth. So you have to decide what kind of pesticide, in what amount it has to be applied, and in which part of the field it has to be applied. And there again, you can make use of the drones for spraying the pesticides in proper amount in proper places. So these are the signatures of the different diseases that you can have over the plant. So here I'll come to some overview of how these diseases can be identified. So this is what the part of machine learning or artificial intelligence. Okay. So what I can have is, I can have a classification tool, disease classification tool, which classifies the diseases based on the features or the descriptors that you extract from the data. And what is data in this particular case? The data is the kind of images that we capture drones or otherwise from the crops. Okay. So what you do is, you extract the descriptors or features from these images and use this extracted features to train your classifier. And once the classifier is properly trained, then I can again have similar such images, extract the features, feed it to the trained classifier to know what kind of disease is present in the plant, in the field, so that I can identify what kind of pesticide will be required and to what extent. Right. So what are the different kinds of features that we can extract? Here you find that, I mean, all these images that I have shown, they are all color images, right? And we all know that in all the color images, we have the different color planes, the red component, the green component, and blue component. So what I can do is, I can find out what is the distribution of the red component, what is the distribution of the green component, and what is the distribution of the blue component, right? So this distribution of green, blue, and red, they are processed in the form of what is known as histogram. And if these histograms are not, so this is what is histogram computed from the red component, this is what is histogram computed from the green component, and this is what is histogram computed from the blue component. And if these histograms are normalized, then what we get is the probability density function of the different intensity values in red, green, and blue components. And then what we can do is, we can find out what is the shape of this using different shape descriptors, and there are different mathematical tools to find out the shape. I'm not going into details of all those different types of mathematics, but just to give you an idea that what kind of descriptors we can extract. Similarly, apart from this color and the intensity descriptors, we can also have what is known as the texture descriptors. Every image is nothing but an array of integers, and typically these integers vary from 0 to 255. So when I have this texture image, and same is for your color image, red, green, and blue components, this is nothing but a two-dimensional array or matrix of integer numbers. So once I have this matrix of integer numbers, I can compute different types of texture properties or texture descriptors from this. just to give you an idea that how I can compute this texture property. This can be done either in the spatial domain or in the image domain itself, or it can also be computed in the transform domain or the frequency domain, for which I have to apply some sort of transformation for the image. So first, let me give you some idea of how it can be done in image domain. So if you look at this texture, you find that there is some variation pattern of intensity values. Okay. So in the intensity domain or image domain, what you try to capture is what is the nature of this intensity variation. And this is captured in the form of joint occurrence of different intensity values following certain spatial relation. And that is what is given over here. So suppose I want to find out that how many times two intensity values, say 8 and 6, occur in the image which are at a distance of 1 and oriented at an angle of 45 degrees. This is just one of the many information that I can compute from this texture image. And if you look at this, I have 1, 2, and 3 such occurrences. But the first pixel is having an intensity value 8, and the next pixel is having an intensity value 6, and these two are oriented at an angle of 45 degrees with the horizontal. So I have 3 such occurrences. So this is one measure. Similarly, I can find out for the same 145 degree how many times the pixel pairs 0, 0 occur within this image. And if you look at this image, you find that there is no instance where 0, 0 oriented at an angle 45 degree occurs in this image. So A 145, 0, 0 will be equal to 0. And so what I get is, for this spatial relation 145 degree, that means distance 1 and orientation 45 degree, I generate another matrix from the image matrix, and this matrix is known as co-occurrence matrix. Once I have this co-occurrence matrix, if I normalize this co-occurrence matrix is simply converted to joint probability distribution, right? And once I have this joint probability distribution, I can compute many features from this joint probability distribution. The features like this: what is the maximum probability, something called element difference moment, something called inverse element difference moment, and so on. And each of these quantities give you some descriptor of the texture image. So you find that this is only for one spatial relation. I can compute this for many other spatial relations. And for each of them, I'll get a set of these quantities. And each of them give you some description, some information of the texture. Right. The other one is I can find out the edges, maybe horizontal edges, vertical edges, diagonal edges, and all that. And from each of these edge images, this is what is done using the operation known as convolution. So this is what is my convolution kernel. If I convolve this given image with this convolution, here the example is different of a building, but the same is applicable in case of images collected from the crops. Okay, so I can have, so you find that this is a kernel which, when convolved with this image, gives you mostly vertical edges. This kernel gives you mostly horizontal edges. Now, if I have a texture where I have only the vertical edges, then convolution with this will give me some output, where the convolution with this will give me 0, right? And using that, I can discriminate among different types of textures. So you find that I can have different types of descriptors computed out of this image, and all these different quantities, when put in the form of a vector, that is known as a feature vector. And given large number of images from the same disease class, I will have vectors which will be similar in some nature. So for all these images, if I put these vectors in my feature space, so if I have vectors of dimension 2, I'll have 2-dimensional feature space. If I have vectors of dimension 3, I'll have 3-dimensional feature space. So all these different vectors will form a cloud, will be very close to each other. Whereas vectors from different classes will form clusters, which is different from the cluster of another business class. Okay. So once I have these vectors, then your classification or disease identification becomes very, very simple. I'll just come over here. So maybe these are the vectors. I take a fictitious case where my feature vector is two-dimensional, right? So these may be the vectors corresponding to one disease class, and these may be the vectors corresponding to another disease class. So once I have that, my simple decision rule can be I can have a straight line separating these two clouds of vectors. So this is one cluster, this is one cluster. I can have a separating plane between these two clusters. And how do I determine the separating plane? For determining this separating plane, I have to have a large number of known vectors. That means from the previously known disease classes, I have to compute these vectors, and those are plotted here. So I know that these vectors are from one disease class, whereas these vectors are from another disease class. And given that, I design or I plot a separating plane between these two classes. So once I am able to plot this plane, I'm able to decide about this separating plane, then my disease identification is very, very simple. So now suppose I have a vector placed over here. This is the vector being computed from an image for which class is not known. I want to know what disease is this. And if that vector falls over here, I know that this is falling on this particular side of, say, disease 1. So I'll say that this plant is suffering from disease 1. Whereas if the vector falls over here, I immediately say that this plant is suffering from this particular disease. Okay, so that's it. That is how our disease identification can be done. So here I have taken example or illustration of a very, very simple case, which are known as linear machines or linear classifiers. You might have heard about support vector machines and all that. So all those fall under this kind of category. In more complicated cases, we may have to go for statistical classification or statistical rules to decide about what is the disease class. Okay, and for that we have to make use of class conditional probability density function, and then for classification we have to use something called Bayes classification rule. So this is what is Bayes classifier. I'll not go into mathematical details of all this. Similarly, you might have heard about the recent techniques of neural network or deep neural network for disease identification. And today, whenever we talk about machine learning or artificial intelligence, the first tool that comes in your mind is the deep learning tools or deep neural networks. So they also do the same thing. Suppose I feed in the feature vectors, the neural network will give me an output which tells you that what is the disease class. Okay. So for that, what I have to do is I have to train the neural network properly. And for training the neural network, as before, what I said is I have to feed in the vectors, the feature vectors, which are computed from the known classes. And from the output, if I find, suppose this vector is fed, which is from disease class 1, so I want that this output 1 has to be high or other outputs should be low. So if I get this output to be high and others to be low, then I know that this, at least for this vector, the neural network is trained properly. But if I get this output high and this output as low, then I know that my neural network is not trained properly. It is giving me a wrong output. So I'll compute an error from here, and using a technique called back propagation learning, I will adjust all these weights, interconnection weights, in such a way that this output error at the output will be minimized, and finally this neural network will be trained. And once this neural network is trained, then for any unknown vector that is fed to the input, the neural network will give you an output corresponding to the correct disease class. So I can use this for disease classification. What happens in case of deep neural network? I'll just go back to this particular slide. Here I said that I can extract the features by using an operation called convolution operation, right? So this convolution operation, in this neural network, what I said is I feed in the features or the feature vectors, then the neural network for the proper classification output. Then the concept came that why not you feed in the image and let the network learn the features, okay, so that I can have an end-to-end system. So I feed in the image. I'll have a number of layers within this neural network, which is known as convolutional network or CNN. The purpose of this CNN will be to extract these features like this, okay? And these features are used for the classification towards the later part of this neural network. So this last or the later part of the neural network is identical with this, which are known as multi-layer perceptrons. Okay, so here I have multi-layer perceptron, and before that I have convolutional. So here I have an end-to-end system. So I feed in the image data. It is just an image, not the feature vector. I feed in the image. I know what is the output or what is the class of this particular disease. If there is an error through backpropagation learning technique, you reduce the error to train this neural network. And this has to be done for all the different disease classes. So once it is properly trained, then this trained neural network, given an unknown image, will be able to identify what kind of disease that particular crop has got. And once you identify the disease, you know the medicine or the pesticide which has to be sprayed. And from the extent of the disease, you can identify how much of the pesticide you have to use. Okay. So this is how your AI or machine learning technique will help you to identify the. So there are 6 smart ways in which your farming can be profitable. You can use this precision technology to sow the seeds so that the seeds can be spread properly. You can use robots for harvesting. You can use drones for field inspection. You can use, or you can even have chatbots for the farmers, right? So the farmers can take an image, feed it to the cloud, and then get the feedback, right? And then you can have recommendations based on AI or learning algorithms. And this is the one where for weed control, you can identify or you can recognize the weed, what kind of weed is that, and you can go for removal of those weeds. Okay. So finally, I conclude that, so here what we have said is, when you go for the smart farming for efficient farming operations, firstly, you have to have set of the sensors which will collect the data. This data can be your moisture content, the data can be nutrient content, the data can be images. Then feed this data to your machine learning algorithms, which can be executed on the cloud, get the feedback, and take actions accordingly. So this use of these modern technologies, the advanced technologies, can help in boost efficiency. It will reduce the waste, and it will improve food safety and food security, and it can also help in sustainability. So I'll stop my lecture here. I think we can have some interaction if you have any questions.
Yes. Thank you, sir, for the session. I would invite the participants, if they have any question, they can unmute themselves and speak.
Good evening, Pravir Kumarji.
Good evening.
It's really a very interesting concept you explained us. Basically, we are from agriculture family background, but unfortunately, we settled down in some medical segment. I gone through your detailed presentation. My question was, uh, the firstly you explained about the moisture detector sensors.
Yeah.
It's quite interesting concept, especially for the dry area farmers. It really, gives a high-end help. So where we will get these devices? What might be the price? Is it viable for the down the line farmers?
Yeah, see, the devices are not very costly. In fact, the sensors that we have, in fact, the sensor that I have shown, let me go back to that. this particular sensor,
Yeah.
it costs something around 100 rupees.
Okay, that's great. And it should keep in multiple areas, right? In 1 acre, how many sensors we should keep on get the
Right.
moisture
Field
value?
area, depending upon field area and the pattern of moisture variation, you can decide that how many sensors you have to place. This
Okay,
has to, it has to be spread over the field. Okay, so
great.
naturally, as you have to have multiple number of sensors,
Okay.
so naturally, low cost sensors are always advantage.
Where we will get this? I mean to say, like, who make an approach for them in case, like,
If
through
you
you.
if you just Google search using moisture sensors,
Oh, it is available in market, you mean to say?
it is available in market. Yeah, in fact, it is available on Amazon also.
That's really great. Thank you very much. Even the disease identification concepts are really amazing. Thank you very much for the inputs to us.
Thank you.
Yeah.
Yeah, I'm Amit Kumar Mittal. May I ask a question?
Yeah, sure.
How can we use IoT or any other kind of electronic gadgets to have check on meanness of monkeys and that these kind of things, that boar or something like that to enter our area of farming?
Yeah, very good question. In fact,
And how costly is that?
yeah, one of the possibilities you can have your camera networks, surveillance camera, right? So using the surveillance camera, you will get the video feed, and then again, this machine learning techniques, you can detect that whether it is monkey or cow or some worker is entering the field, because the movement pattern of monkey, the movement pattern of cows, the shape patterns, and the workers, laborers, they will be different. So from the camera network, the data that you get, the video data that you get, that can be analyzed using machine learning techniques to identify what kind of creature is moving in the field, whether they're doing any damage or not. And you can generate an alarm. It is possible.
No, I'm not talking of identifying them. We already know that which kind of, wild animals we are getting, which kind of birds we are getting there. No, how to take care of that menace through some electronic, kind of.
You mean to drive them away?
Yeah, to keep them away from that.
Yeah, exactly. Yeah. So, see, when we're talking about IoT is not only for collecting the data, because when you talk about IoT, it is basically sensor actuator loop. So when I'm talking about,
they are giving agriculture demonstrations, sir, across India. Kenapa, sir? मिलेगा मंडे और 3 दिन बस है मेरा लिए जय जिंदाबाद
Yes.
yeah,
So
what I was saying is, you can have the cameras, surveillance cameras, to give you the data. You can analyze the data to identify what it is. Then using that information, you can actuate the actuators, which maybe say some horn or some buzzer, something like this, okay, which can be used to drive away those animals. Okay, those can be devised. It is not that difficult once you can identify what it is.
Generally, what is the cost per acreage of this kind of system, which can identify as well as take care of hooters and all? Generally, as an average, I just want to know.
See, the material cost will not be much because surveillance cameras are available. I mean, each surveillance camera can be within a cost of say 10 to 15,000 rupees. You can have it, or there may be even lesser, cheaper cameras available. But your cost will come in the development of the AI-based technique. So whatever is the labor comes over there. And even these days, many of the tools are available in the public domain. So it is not that difficult. I don't think it will be very good.
And what is your take about solar fencing?
solar fencing, yeah, it can be right, but I'm afraid that using solar fencing, that might be detrimental to human beings as well. I mean, when you try to drive away the animals, maybe you'll also be driving away the human being. That might be a problem.
Hello.
What I've been told is quite safe as far as current point of view. It is basically the voltage 60 volt, more than 60 volt, which basically hits you.
Mm-hmm.
It doesn't make it like we are using normal 12 volt battery or 24 volt batteries.
Mm-hmm.
And generally these batteries don't harm anybody. It just gives a shock. That's what I know. I'm not 100% sure about that. It just gives a shock, kind of shock to the animal, and nothing else. It doesn't harm them actually.
Okay. But maybe the animal lovers may not like it. That's a controversial issue, right?
Hello.
Okay.
Hello.
Not very proven in your point of view. It is not very much proven as on date.
I will not advise for it.
Okay. Thank you.
Hello.
Thank you very much.
Hello. Hello, Praveen Kumar ji.
Yes.
Hello.
Yes, I can hear you. Please carry on.
प्रवीण कुमार जी, मैं ये पूछना चाहता हूँ कि आर्टिफिशियल इंटेलिजेंस टेक्निक पोस्ट हार्वेस्ट में अगर अपन फ्रूट की या वेजिटेबल की अगर ग्रेडिंग करते हैं तो उसमें अपने को ये पता चल जाएगा ग्रेडिंग में कि वो उसके अंदर कोई पेस्ट तो नहीं है या कोई डिसीज तो नहीं है या वो सड़ा हुआ तो नहीं है. इस तरह का ग्रेडिंग का अपने पास कोई
it is possible.
तो वो थोड़ा सा कुछ गाइड करेंगे कि वो किस तरह से हमको वो टेक्नोलॉजी अवेलेबल होगी.
Yes, we can do it offline. Whenever you need any such guidance, please you can contact me. We can do. Yeah. Right.
आपका कॉन्टेक्ट डिटेल?
I think you can get it from the organizer.
Okay. I am contact.
Hello, sir.
Yeah.
Hello.
Yes, Mr. Bharat Sharma.
Sir, I have a question regarding this slide that you just closed, soil moisturizer.
Okay. Yes.
As you said that these equipments are available easily, but what about the ways of interpreting the data? Like, do we have any kind of a device that we have to use with them, or is there some kind of a software platform with which we can
See, this particular device, I mean, the components which are shown here, it is only collecting the data, and this data has to be processed for interpretation.
Yes, sir.
Okay. So that the calibration and the signal processing tasks that also come into picture.
Okay.
So the manufacturers, they usually give this as a package.
Okay.
So it is not only the sensor. They are, along with this, they also give one microcontroller, or these days even Arduino-based hardware, programmed Arduino, which actually tells you what percentage of moisture is present in that particular. So this comes as a package.
Okay, sir.
Okay.
Thank you so much.
And that can be interfaced with your microcontroller and all.
I got it. Thank you. Thank you.
Hello, sir.
Yes,
Hello, Ravi, sir.
Yes.
Yeah.
Is somebody else asking the question, or can I go on?
Yeah, please go ahead, Mr.
Okay. Pravi sir, hello sir. My name is Tapan.
Yeah, sure.
I was wondering how good the weather, rainfall, and sunlight data and the predictions are when it comes to India.
Okay. Have you, do you check the AccuWeather site? AccuWeather.com. Okay. So that particular site, whatever prediction it gives, it is pretty accurate. Pretty accurate.
Hello, sir.
Yeah. Can you hear me?
Yeah, sir.
Yeah. So whatever thing that the weather forecasting or weather prediction as given in the AccuWeather site,
Yeah.
it is pretty accurate. Quite
Okay.
accurate.
Okay.
And those data can be used for any prediction. I mean, with almost more than 95% confidence.
Okay. Okay. Is it okay if I ask one more question, or would somebody else want to go ahead?
Yes, please go ahead. Please go ahead.
Okay. So all these Internet of Things, sir. I mean, isn't it true that the penetration of internet connection into India has just started going into rural areas, and the electrification has also just started, isn't it, for the past 2 to 3 years? So I was wondering, wouldn't it also need training of the local personnel for these things to go on?
Sure. It's a very, very important point that you have raised. We need awareness among the local youth. See, sitting in IIT, I'm talking about IoT, I'm talking about machine learning, I'm talking about AI, all those things. But finally, the end user, they are not technical people, right?
Yes.
People who are working in the field, they are not technical. If I try to explain what is an IoT and what is AI or machine learning, it is just hip to them.
Right.
What they need is you give them a solution and give them training that how to use that solution. Right?
Right.
So finally, you have to give them the package and the training to use that package. That is what is meaningful to those people. Technology, the technical part is not really the functional part is right. So we have raised a very, very important point of training of the local people and making the product which is actually useful to them, usable by them. That is what is the need of it.
Yeah. But you must be seeing a lot of adoption in organic farms and urban farms and vertical farms, isn't it, sir?
Right. But see, the people who are doing for vertical farming, they are experts.
Yeah.
They are not
Right.
right.
Good evening, sir.
Our target should be the villagers.
Okay.
Good evening,
Thank you
sir.
so much, sir.
Good evening, sir. How AI is useful in predicting the
Soil nutrition.
soil nutrients like NPK using image analysis?
No. NPK is not using image analysis. It uses optical techniques. I mean, it imparts light of certain wavelength to the field and then gets the reflected light. And from the attenuation pattern of that reflected light, it tries to estimate that what is the content of nitrogen, phosphorus, and potassium within the field. So that is why I said that there are 3 bands of wavelengths. So there has to be 3 kind of light sources. One of them will try to estimate nitrogen, the other kind of will try to estimate potassium, and the other kind will try to estimate the phosphorus.
Sir, but now some research work is going on using image recognition. They are predicting the nitrogen, phosphorus, and potassium content in the soil.
It has not come to my notice yet.
Okay, sir.
Maybe I'm not saying it is impossible, might be, yeah.
Sir, how AI can be used in supply chain, sir? Supply chain and management.
So
yeah, that is basically data analytics.
Yeah, okay.
It is basically data analytics. It is not only your field data, but you have to also collect the data of demand, your supply line, what kind of infrastructure that you have. Okay. By analyzing all those data, you can use machine learning in supply chain management as well. In fact, the marketing people are already doing it. They're using machine learning or data analytics techniques for supply chain management.
Okay, sir. Thank you.
So,
hello, good evening, sir.
Good evening.
Hello, good evening. Yes, can I ask some
yes, please
question?
go ahead.
Yeah, please.
As you discussed earlier, you talk about the different kind of diseases. My question is, what are the cause or causes of rice infection?
What are the cost of?
So what are she's
Rice
asking what are the
infection.
causes of? So Of course, this is an economic question.
What are the causes of infection?
Yeah, so I think this
Yes.
is an agronomic
What
question.
are the causes?
Okay. This is something I'm not really an expert on this. I think somebody from agricultural engineering or things like that will be able to answer. But
Yes.
a few kind of things that I have gone through literature might be due to your bacterial infection. Okay. In fact, all the images that I have shown, those are due to infection of different types of bacteria. Okay. And this sort of things will get not only for infection but also for malnutrition, right?
Okay.
So
Thank you, sir.
the plants may get dry because of lack of water, lack of moisture. So that is also possible.
Sir, what is your research area? Your interest research area?
My research area is IoT, image video processing, machine learning, so stuff
Sir,
like that.
Yes, so I have another very interesting question coming from the chat box, which is how to diagnose internal damage. Like if the pests are damaging the fruits or vegetables from inside, is there any IoT or AI technology which can help?
Okay, in those cases, it is possible to diagnose through thermal imaging. Because if you look at the thermal pattern, the temperature pattern, the temperature, the temperature which is radiated by the fruits or even in human body, it depends upon what is the condition, the physical condition, right? So even the research is going on for cancer detection using thermal images. So the cancer inside, it is not always necessary that you have to go for PET imaging and all that. Even using thermal imaging, you should be able to detect. So the same kind of technique can also be used for detecting or estimating the internal damage. So instead of simply using the optical images, one can use thermal imaging.
Sir, there is one more area of concern. I'm Amit Kumar Mittal.
Yeah, please.
Lot of technology we have developed, including AI and other things.
Right.
Are we really able to reach the marginal farmer, which is 80% of the total population? Because that all the policies, all the technologies, all the developments, people want farmers to approach them, which is not the case. This marginal farmer is not going to approach industry. It is not going to approach academia. It is not going to approach government. I'm from a village where the main occupation is agriculture only.
Okay. Sir, let me tell you,
animal husbandry. But I am MTech. I am MTech from IIT Mumbai. I know about all these things, where to get, how to get it done, how to get it implemented. I can't convince the people in village to use the technology. So my request is, in case some real program can be made that all these factors together, industry, academia, or technologies, they basically approach farmers and convince them and implement it. Then only this will be successful.
Yeah, you're right. In fact, as you said that you are from a village, I am also from a village. My village is just 20 minutes walking distance from Bangladesh border. A village where there is no electricity even today. There is no metal road. So I can easily understand your concern. I feel your concern. I have seen those villages. I have gone to that village just an year ago. I have seen the difficulty that they are going through. In fact, I left the village more than 35 years ago. So now I'm not a frequent visitor, but I go there occasionally. So that is what I'm saying. What you are saying is absolutely correct. We are doing research in laboratory. We are doing research in higher educational institutes. But actually transforming or translating these outputs to the actual people who really need, there is a gap over there. So for that, proper planning is required. The will is required. The correct thing that you have brought out, right? You have raised a very, very pertinent question and useful question. It is required. We still lack over there.
So, like this webinar itself is a, it can vouch for that. How many marginal farmers are there in this webinar?
Yeah. True.
I don't think anybody.
True.
So the point is that we have to reach farmers.
Yeah, so sir, this program is for agri entrepreneurs or aspiring entrepreneurs. So definitely here we have people who are potentially going to take up entrepreneurship and solve problems. So the agenda is different here.
Sir, my question is.
Hello.
Yes, please.
Professor Biswas, I have another question related to the discussion.
Some girl was asking something. Can you give her a chance before I take up your question?
Sure.
Yeah, sir. Sir, my question is, sir, the cost of input in doing precision farming is much higher than conventional farming. So, how is there any successful model in India which is doing well in precision farming, or it is just on the paper that yeah, we can do this, we can do this?
The cost, you are saying cost of precision farming is more than the conventional farming. Is it your question?
Yes, sir.
Yeah, maybe initially the cost will be higher, but once it is true and it is widely used, see, for example, all the sensors that I have talked about, these are mostly one-time investment, right? Until some sensor goes wrong. And it can be used multiple times. So initial investment, you are right, the initial investment may be high, but at the same time, it will be compensated through reducing wastage. As I said, that say nutrition or even pesticide, without proper monitoring, if we spray them just blindly, there is a lot of wastage. So that wastage can be reduced, right? So it is true that initial investment is high, that is compensated through reduction of wastage, and over the time, it will be profitable. So again, a proper planning or the proper infrastructure is required so that maybe the farmers can be given some sort of subsidy. So for example, you might be knowing that for solar cells, in the village areas, wherever the solar cells are being installed, those are highly subsidized.
Yes, sir.
Right? So similar such sort of subsidy model can be thought of, and the planners have to take care of it. So many of you who are the budding entrepreneurs, maybe you can put proposals on that.
Sir, in India, do we have any successful model who is doing very well in the precision farming?
Successful laboratory models are there.
Okay, means right now there is not any practical, in practical world we don't.
Widespread application, to my knowledge, is not there yet.
Okay,
but successful laboratory models are there.
Okay. Thank you, sir.
Okay. Yeah.
Hello, sir.
Hello, sir.
So, yes. So we can take one last question. Yes, please go ahead.
Hello, sir. So, sir, as we just talk about the soil health and sensors in using there is also another allied area is animal husbandry and poultry culture. So, how can we use IoT to manage their health, and what is its expected applicability in India?
Right now, I may not be able to answer you, but see, the use of IoT is you have to identify the proper sensors, right? Because the whole of IoT is around sensor loops, right?
Yes.
So you have to survey the market, identify the proper sensors depending upon the kind of application that you're thinking of. So once you identify your application and you identify the sensors, I think whether it is IoT for farming or IoT for poultry, the infrastructure, the technological infrastructure remains the same.
Yes, thank you, sir.
Nigank, I think one gentleman was asking something.
Hello, sir.
Yeah.
So I have a question regarding that, because you told that only laboratory successful are done, as no practical things are then. How could we convince the farmers about, as there is no successful thing in practicality, as this is the initially thing, right?
See, there has to be a lot of workshops, inviting the farmers, tell them what is the benefit of this farming,
Okay.
right? How they can be benefited. It has to be. They have to be convinced.
Okay, sir.
Okay. Once they are convinced, then they will go for it. If they feel that there is some real benefit, then definitely go for it.
Okay, sir. Thank you, sir. That's the question here.
Okay.
I want. As far as I know, there are few entrepreneurs, maybe startups, who have entered into this agriculture after doing MBA and something like that. Somewhere in Maharashtra, so they have implemented. Their whole of the farm is basically IoT based.
Okay.
And it has been running for the last 1.5 years.
Okay. So that's
I'm not able to recall exactly what is the name of that farm, but it is a startup who is basically, there are two batchmates of IIT who did MBA also from, I think, Ahmedabad.
Okay.
They ventured into this farming, and basically organic farming with the help of all these gadgets.
Okay. That's good. Yeah. Okay. Okay. Thank you very much.
Okay, thank you, sir, for the wonderful discussion, and we also had very nice interaction. It is a very exciting topic, so definitely I am pretty sure a lot of people will be having more questions. Please feel free to send us your queries. We will be happy to connect you with Professor Biswas for further interaction. Thanks a lot, sir, for the...
Thank you very much, sir.
So thank you very much, sir. It was really enlightening.
Bye.
Thank you, sir.
Thank you very much, sir.
Thank you. So next, we have a talk by Mr. Anand Verma, who is co-founder of Fasal. Just now you heard about the technology, some of the popular applications of AI and IoT in agriculture area by Professor Prabir Kumar Biswas of IT Kharagpur. Now, next we are going to have a talk by a very interesting startup, which is Fasal, and which is basically implementing this IoT and AI solutions in farms. And it has successfully demonstrated its applications in India. So they will be talking about their, Mr. Anand will be talking about the entrepreneurship journey that he has had with Fasal. So let me welcome Mr. Anand and introduce him. So Mr. Anand Prakash Verma, he is co-founder of Fasal. He has previous experience also in the corporate as well as several other startups he has worked on. So he completed his BTech from Vellore Institute of Technology in 2011, and after that he did his MTech with Triple IT Bangalore in 2014. After that, he was in the software development industry with companies like Ambassador and Mass 360, which is an IBM subsidiary, as a software engineer and lead. Following that, he was technical lead in Covium, and following that, he embarked upon his startup journey. He co-founded FostByte, which is basically a knowledge platform for startups and technical innovations. He is also a startup mentor on Manush Labs. He is actively involved in mentoring startups in his areas of interest. In 2017, he founded Fasal, which is basically pioneering several IoT and AI-based solutions in India and making them affordable and reachable for the farmers of the country. So I welcome Mr. Anand to discuss and enlighten the audience with his experience and journey that Fasal has undertaken so far. Welcome, Mr. Anand.
Thank you. Thank you for this, very detailed and elaborated introduction. I think I don't need to add anything else apart from that, what you have already mentioned. Before really starting my presentation, I was just, I joined here a few minutes ago and I was just listening. One thing I want to tell you is that Precision agriculture is no more a workshop or a lab thing. It has been implemented. It is in the farms, in the field, really well. So those who are still considering that it is a experimental or laboratory work, please get away from those misconceptions. It is pretty well accepted, and right now it is a cusp of disrupting the entire agriculture in India and in other parts of the world as well. So with that, let me start my presentation. And just feel free to jump in and ask questions if you have. Let me and first let me finish my presentation, or maybe in between if you have any questions, just feel free. Please let me know if you are able to see my screen.
Yes, it is visible.
Yes, sir.
It is visible.
Perfect. So
Yes, sir. Yes.
perfect. I think I got the answer. So let me start. Let me start with the topic here. I think the topic really is about AI and IoT in agriculture, but I think in a broader way, I would also like to explain, how we, what problem we identified and how we built this solution, how we took it to the market, how we deployed in farm, how we convinced farmer to use certain technologies to improve their productivity, to improve their yield, to improve their quality, etc. But I'll probably touch base upon the different technologies that we use and how we use that. So let me start with identifying or telling you the core problems that we had identified. Now, when we look at agriculture, and if you look at my background or my co-founder's background, both of us come from agriculture background. My dad is a farmer. He is a seed producer. He produces cauliflower seeds, and my family is into farming for I don't know, from many decades. So my grandfather, his grandfather, everybody was farmer in my family. I was the first generation engineer who who did not take farming as a profession and wanted to become an engineer, which I eventually did. But again, my instinct got me back to where I am today. The core problem that we had identified, when we were building Fasal, and it took us time, it took us really a lot of time to really understand these core problems. And since we had certain backgrounds into farming, that gave us some insight into identifying these problems altogether. Now, how we really started all this was experiment that we wanted to do. So we were pretty well stable in our jobs. We were happy on a side track. We wanted to do farming as a hobby. And given our background, we started researching about it, and then we realized there's actually a lot of problem that we need to first solve to even start our agriculture practice that we had thought of starting, and that led to where we are today. So while doing that research, we identified that all the decision making that is happening on the field on a day-to-day basis is not at all right. And the reason for it to not at all right is because all the decisions that we make is driven by guesswork, is driven by traditional wisdom, is driven by intuition. It is driven by certain calendar day schedule that has been created 20, 30 years, 50 years ago, and we are still following that. Where on the other side, if you look at, there's a climate change, and everybody accepts that there's a climate change. There's soil degradation that has happened. The entire sea, we have new varieties, new seeds, which has been developed and put into the market. So how can we still rely on the same practices that we were following? So those were the fundamental questions that we understood, and then we thought, okay, how we can really solve these problems, because the problems that we have today in terms of making guesswork on field on a day-to-day basis in terms of irrigation, fertigation, or any other activities that we plan for our crop is really plugged. And not just this, this also contributes to a lot of sustainability issues. For example, 20% of the greenhouse emission is just because of agriculture. 90% of fresh water in India is being used in agriculture, and it is not being used optimally. Most of it goes for a waste. The consequences of the problem were not stopped with just these. The major problems were after you have gone through this entire growth cycle, crop growing cycle. The export ratio in India is 1.5%. And we are producers of we are producer of some of the largest commodities in the world. Still, our export ratio is less, and the reason for that is the poor quality of crop and high residual limit. we and everybody knows that we spray left, right, and center. All our spray is driven by certain calendar day schedule that is defined and given to us, not by really measuring whether the disease will happen or the pest will happen or not, but rather we keep on just spraying, considering that in this phase of the crop cycle these are the diseases that can potentially harm my crop, so I should better protect it rather than losing it. This is again a mentality that required a lot of time and effort from us to change. But this is why our export ratio is very low, because we have extremely poor production quality in India and high residue in the crops. Apart from that, as I was mentioning, the the water utilization, the fresh water utilization is 90% in India, and which is the highest in the world also. And out of this, only 80-85% water that we use in India is actually used in only 5% water is actually used in domestic. Rest all is industrial, and the remaining 80-85%, 90% is used in agriculture, and most of it actually goes for a waste. Because what we end up doing and what we have realized based upon all the work that we have done in last 3.5, 4 years is that most of the time farmers are over irrigating their field. There is no right way to measure the soil moisture levels in their crop, and in their soil. There is no right way to measure what is the current evapotranspiration rate, what is the current, what is the forecast, what is the accurate forecast for rain, and when is the ideal time, and how much is the ideal amount of water that I should put in my crop, and that leads to over irrigation problem. The third major problem, and a very debatable problem, is the production gap that we see. So there are certain states which has more land under cultivation. But they are still not able to produce high. Of course, there are some dependency on the weather, on the soil itself, but then larger part of it is in practice, insufficient practices that they follow. Weather and soil is something that we cannot change, but we can still change our practices. We can move to a better practice of growing. We can move to a better crop at all to improve these production gap. So these were the problems and impact with which we really started our journey. And let me drive you through the technology that we implemented after we understood this problem in detail and figured out a solution that could really solve this problem. Now, to tell you all the benefit that bringing IoT and AI can do with respect to farming are listed down here. So if you implement IoT and AI, again, I'm using this term just by a mean of telling that the technology is built using these things, but essentially the entire solution, the benefit of this entire solution is that any resource that you're using, whether it is water, fertilizer, spray, chemical, everything is being optimally used. It has not been overused, it has not been underused, it is being optimally used. If you use these resources optimally, you are going to save costs, because most of the time you're over irrigating, over utilizing all the other resources. Apart from that, if you use your irrigation, fertigation, and other activities right, you know that you will have a higher crop yield, because most of the time crop yield is really dependent upon, apart from weather and soil, is also dependent upon how you have really irrigated it and fertigated it. If you do all these things well, you will have a better quality crop and export quality crop. And once you have done all these things, you are also very sure that you have had certain impact when it comes to sustainability. You have reduced water, you have saved water uses, and you have saved some water for this country. Now, who we really are, as I told you, precision agriculture is no more a lab thing. If you're still thinking that it has not come to mainstream, then I think we are still 3-4 years behind in our thought. Precision agriculture is pretty much active, a very, very well known and well accepted application by the industry in the country, by the customers. Fasal essentially is an IoT-based AI-powered platform for horticulture crops. When I say horticulture, there is a reason for that. Probably I'll come to that a little later, or why I'm not saying agriculture as a whole. I will say agriculture as a whole someday. We will do it for someday, but right now we are focused on horticulture. So what we really do is we capture real-time data, from on-farm sensors. It's a small device that we deploy on sensors to collect data. And then we provide farm-specific, crop-specific, and crop stage-specific, very actionable intelligence or advisories to farmer in their own language. And the kind of advisories or the kind of things that we send to farmer is, it's very similar to like आज के दिन 5 बजे आपको अपने खेत में 5 लीटर पर प्लांट पानी डालना है. Now this is what we send to farmer. How this has been derived is we measure what is the moisture level present in the soil, what is the moisture level present at the feeding root, what is the moisture level present at the supporting root, and then we try to understand what is the evapotranspiration rate, how much water crop and the soil is losing by transpiration and evaporation. So we try to find out evapotranspiration rate, and then we try to find out whether there is a possibility of rain or not, by a mean of very microclimatic forecast. And based upon all these things, we try to evaluate in this particular stage of the crop, what is the water requirement that is needed, depending upon its physiology, its morphology, and various other factors that involves in crop physiology. And then we tell farmer that this is the water requirement that your crop needs. We have, as I told you, we have not just been used by these guys. We have been pretty been funded by VCs, and we have got very good grants as well. We have been covered by almost all the national media. So do check out these things. Will help you understand more about precision agriculture and adoption and its adoption in India. Now, how we really do it, as I explained to you, we deploy these, small devices. Believe me, this is really small. So these devices in the farm, and these devices basically has all these sensors that is required to collect the data points that we need to provide those insights. So, for example, we collect data like macroclimatic data. What is the rainfall? What is the wind speed? What is the wind direction? We calculate canopy level data, like what is the canopy temperature, what is canopy humidity, what is canopy leaf fitness, what is solar intensity, what is lux, and then below the soil, what is soil temperature, what is soil moisture, what is soil other factors like EC and pH. And then all the data goes to, continuously gets sent to a cloud server where we have built these crop specific algorithms or learning models that basically churns the data every time they receive data. And then depending upon what crop farmer is growing and what future tells in terms of weather pattern, it basically goes and triggers a message or alert to a farmer saying this is what going to happen, and you better take this particular action on your crop or field. And this is how this entire system works. And in terms of data collection, this is not we don't only collect data from sensors. Of course, sensor is one thing that provides us real-time data, but we also collect data from satellite in terms of, of course, you might be knowing about NDVI and other methods by which you can collect remote sensing data. And we also try to identify, what are the hotspot area from where the disease will happen. So Fasal not only tells that a particular disease is going to affect your crop, Fasal also tells that which particular area of your field is going to be affected first. So you not only take a preventive measure, but you also go and spray at a very local, hyperlocal, or a very localized area. You don't need to spray in your entire field, and this is how you reduce your cost.
Hello, I think we have lost your screen. Anand,
He's removed from the meeting, I think.
no, I think he's there. Anand is. Hello, Anand, are you still here?
Sir, he was not there.
Okay, so let us wait. I think there is some. I'll just try to contact him. Maybe there is some connection issue.
Correct.
Is Anand. Is here. But your number is not here.
Hello. Disconnecting, sir.
I request all of you to please wait. We are trying to contact Mr. Anand once again because of, I think, because of connection problem, we have lost his connection.
Where from he is calling? Information. There is some technical error.
Kindly give us a few minutes. We're trying to, yeah, so he has joined again. So, Anand, I'm sorry that we got disconnected. Yeah, so somehow, I'm not sure, because of connection problem maybe. So you are muted, please unmute yourself. Please unmute yourself.
Hey, I'm really sorry. I don't know how that happened.
Yeah, I'm sorry also. So let us continue. So we can share the screen again and we can continue, I think.
All right. You have to tell me where I was because I think I went into the flow for a couple of minutes after I got disconnected. Hello?
Yeah, yeah.
Can you help me understand where I got disconnected?
Yeah, you're talking about that at specific areas you are trying to spray the fertilizer pesticide basically so that you can save the overall cost. So
all right. I'll just start from here.
Ananda, it was the slide after the benefits of AI and IoT based smart farming.
I think it's slide number 8, I think.
Probably, yes. Yeah. Yes.
Let me start from here itself. So I think I did explain you how the technology works, how we collect data and how that data goes to our cloud servers where all these AI models and machine learning models run and then produce certain very actionable advisories to farmer in terms of when they need to irrigate, when they need to fertigate, when there is a disease pressure building up so that they need to take a preventive spray, or what are the other different activities that they need to do on their farm to make sure that their crop grows healthy and well. Now, coming to what are the different kind of sensors that we use is I categorize these sensors into really three major categories, where the first one was the macroclimatic sensor, which was wind speed, wind direction, and rainfall. Now, macroclimatic sensors are those who basically does not, or microclimatic parameters are those who does not changes in a large area. It largely remains same. For example, your wind speed, wind direction, rainfall does not change in a large area. But when it comes to microclimatic parameters, that is canopy temperature, canopy humidity, and canopy leaf wetness, these are very, very, very dependent upon your farm. So if you are growing one crop, let's say you're growing grape, and there's a farm 100, 200 meters away, and that farm has chili or tomato, the canopy parameters will be very different. Not a huge difference, but you will have a significant difference, and that difference is very useful because that's how the disease and pest propagation really happens. So we try to monitor that. Apart from that, we also try to monitor parameters below the soil, which is soil tension, soil water tension. at primary level and secondary level. Now you understand primary level is basically all the feeder routes from where we, the water intakes happens and the fertilizer intakes happens. Secondary route is, is for providing the crop, providing strength to the crop. So if now you know that if your irrigation is more than it, it is nothing but leaching down the soil and it has not been useful. If it is not much, then it is not even reaching to the primary root level and it has not been useful. It might get evapotranspirated. It get transpirated from the soil. So we try to understand these in very detail, and then based upon what are the evapotranspiration rate and what is the available soil moisture level, and depending upon what soil type you have, what crop you're growing, which stage is the crop in, we try to tell you how much exactly the farmer, how much exactly they need to put water into their crop or how they have to irrigate. So this is really what we do. Precise irrigation, as I talked about already. Disease and pest management, as I told you, most of the disease and pests are nothing but function of weather conditions. Now, it is, I mean, some of the diseases, of course, are not a function of weather conditions. They are airborne, but most of the disease are. So if you take an example of downy mildew, powdery mildew, anthracnose, a bunch of diseases, they are, the pathogen germinates, or the pathogen basically lives in a very suitable and congenial environment. So there is a congeniality in environment that causes certain pathogen to germinate and sustain and become adult and then harm the crop. So we try to identify, based upon the data that we get continuously from the farm, we try to identify those congeniality in environment, which can give rise to certain disease or pest later. And then we give a forewarning alarm to farmers saying, "Aapke khet mein ye disease hone wali hai, or your crop might get affected with this disease in next 3 to 4 days. So you better go and scout." And then we also tell them this is the area from where the disease propagation will start, depending upon the satellite image that we capture, or the NDVI and EVI images that we capture to find out all those hotspots area where there is a there's a change in the crop pattern when it comes to disease and pest. Apart from that, where we use AI a lot is really the microclimatic forecast. Microclimatic forecast is very different from the forecast that we get from IMD or other weather companies. And why it is different is most of the forecast that we get is really a taluka level or a district level, city level forecast, because they have they have weather stations deployed 1 or 2 in one city. Now that's not sufficient to provide you microclimatic forecast at your farm, and you know that, right? You might have been observing that the temperature says it is going to remain 22 degree, but at your farm it might be 28 degree or might be 16 degree. So there is always 2 to 3 or 4 degree variation, and those variation are the major factor for any disease or pest to happen. So we try to estimate that. We also try to estimate rain prediction for next 7 days with a very high accuracy. And we are continuously working on that. The reason for that, again, is as we collect more and more data, as our models become more and more smart, our accuracy also increases over time.
So Anand, I have a couple of questions here. First thing is for the NDVI, etc., you are using satellite or drone data?
Currently, we are using satellite because, again, drone is something which is operationally not very feasible. Of course, it will provide probably much accurate and better data, but since we already have this prediction system in place, so again, to better understand this whole thing is, drone and satellite imagery is really not prediction. It's rather detection, right? You can early detect, but you cannot predict. Where we excel, or we try to position ourselves as, we are a prediction company which predicts or gives forewarning alarm about any stress condition or disease or pest that can happen to your crop. Now we incorporated satellite to give an early detection as well, so that when we tell the disease is going to happen, we also locate the area from where it will propagate or from where it will start. So to answer your question, we use satellite, but again, the entire infrastructure or the system is built in a way that satellite or drone is just a mechanism of collecting data. All the algorithms really work on any source of data.
The other question that I have is regarding the microclimate. So weather station deployment and microclimate assessment, the question that the farmers will ask is that whether there is any quantified benefit so far, like whether we have data which is showing that means deploying weather station and getting the microclimate detail is really helpful in overall yield improvement or saving the crops, and also what is the region covered by each of these, like per acre, or how many of these are required per acre, or in other words, one particular weather station, what is the area covered by it?
Definitely. So the first thing, we don't call it weather station, we rather call it IoT station, or because this is weather station plus plus. Now, to answer your second question, typically we recommend 1 hectare, which is around 2.5 to 3 acres of land for one such IoT station. And the third question is whether it has been, how we measure the impact is, I think, that is the reason we exist. So we have very well defined case studies. Probably if you just look at our website or follow us, you will see farmers talking about this a lot. The kind of improvement that they have seen, or the kind of impact that they have seen. And again, it varies crop by crop. So depending upon what crop you're growing, what was your earlier cost of cultivation versus when you have a system like Fasal, what is your current cost of cultivation, then you'll easily be able to define or justify whatever improvement that they have received. But yes, to answer your question, I think all these things are the reason for our very existence.
Okay.
Mr. Anand, is it? Sorry, go on.
Sorry, please, if you have any question.
Okay, yes. I'm not sure if this is probably a part of your presentation down the line. If it is, then I would wait for the answer. In case it isn't, how busy did you get this year with the locust attack all over India? And do you have any tales to share?
No, we don't do that. So we are not able to predict locusts.
Okay.
All right. So
what is the cost of installation of one station per hectare? Approximately, just an idea. And where from you get the power, and what is the mode of transmission?
Correct. So I'll try to answer it again one by one. The cost of one station is 1/4 of your drip irrigation. If you know how much drip irrigation will cost you in your 1 acre, just divided by 4, that is the cost of this weather station. Of course, there is no subsidy here. And then when it comes to, so your second question was how it get power and transmits data. So it is solar power. It is designed in a way that it collects data, goes into a deep sleep mode, wakes up next hour or next 15 minutes, whatever interval we have configured. And then it uses cellular network, it uses LoRa, it uses other different, whatever mechanism is really available in that area. So right now, most of the deployments that we have done around Maharashtra, Chhattisgarh, MP, Karnataka, some places in Andhra as well, it uses cellular network, but now we are coming up with LoRa network as well, especially for places where cellular network reachability is very weak. And the way we use it is, again, we have a mechanism by which whatever network is available in that area, the best network, it automatically picks that. So if Vodafone is available, BSNL is available, Airtel is available, you don't have to worry about it. The device will take care of it.
Okay, thank you. And one more thing related to that only, like, solar is again an issue. At some places, you may not get solar light. So do you have a storage also along with that for some time?
Correct. I think very good question here. So yes, definitely. So we do have storage. The device can store up to around 2 to 3 days of data. But before that, I also want to highlight that the way we have built this device is, let's say if it is full charge once, if there is no solar for next 60 days, there's no problem. It is able to work.
That's good enough. In fact. And this includes the cost of drip irrigation also. Like you mentioned, the cost of this is approximately 1/4 of drip irrigation. So it does irrigation also along with that?
No. So no, I think you meant whether this comes along with drip irrigation, or this activates drip irrigation?
Yeah. That's what my point is.
So it does not come with drip irrigation. For example, if you have a drip irrigation already installed in your farm, and then that drip irrigation supports automation, you can connect your drip irrigation with Fasal, and then it will work out. You can configure. So in Fasal, you can configure saying if your soil moisture level goes below a certain level or above a certain level, then you can turn off or turn on your motor or your irrigation pump. So that you can do.
So it is basically integrated with that system of irrigation.
Yeah,
once
so
it is installed.
It has a capability to integrate, but then
with that. Okay.
Yes, but then you have to check
and
with.
That can also be done automatically. Like you can program that also. Whenever it gives command that there's a time for irrigation for half an hour, so that it does that also, or you have to do it manually.
No, you can actually configure all these things. So you can configure all these things inside Fasal. You can say that if my soil moisture level goes beyond this, which means my soil is dry, so turn on the motor, and then when my soil moisture comes below this, turn off the motor, and then when you turn on the motor, these are the this is how you basically the way you configure your drip irrigation, how much liter per plant you want to irrigate, and whether it is time based or volume based, all this configuration can be done.
Actually, why I'm asking this question, there is a lot of problem with electricity in rural areas. Okay, like suppose it gives a command at 5 o'clock, that you irrigate at 5 o'clock. That time electricity may not be there. So these are the practical issues at ground. That is one thing. So I just wanted to know from that point of view.
No, so in that case, we cannot really do anything. Of course, if power is not there, then I don't think. I don't have a solution for that, at least as of now. The solution that we have, or the one which we provide, is any drip irrigation company that has a good automation system, drip irrigation automation system, can connect to our system and automate their entire drip line. If any, so for example, there is a company which provides solar pump. And they have integration with Fasal. So if you use their solar pump, you can configure these parameters, and your solar pump will be automated.
Okay. See, another issue is that, like, suppose I have got a mango orchard. Sorry, I am taking a lot of time. Suppose I have got a mango orchard where the height of the plant, height of the tree is itself very high and it's very dense. So is there any issues in installing such kind of things there? Like, getting solar radiation and height of the tower and safety of these towers because of some menace of wild animals, something like that. And then what is the commercial viability? Like, can you install only one in one of the village? Like, I got 2 hectares of land. So I'll be needing around 2 as per your assessment. So can you install only 2 in a village and it can work commercially? Is it really commercially viable for you?
Okay, so I think as I was explaining you earlier, maybe in my earlier slide, when I said we are very crop specific. So the way we work is, let's say if you have 5 acres and just one crop, you can install one and it will provide you all the advisories. But if you have different crops, then all the crops have different needs. Their assessment is very different, and you also very well understand that. So in that case, basically you have to put more units. Now, when it comes to whether you can deploy in one village, of course you can do that, but then advisories will not be that precise. It can still provide you a very generic advisory, but when it comes to precision requires certain effort to take. So of course, it can do it, but it will not be recommended from our side or from anybody really. We always recommend it that whatever crop that you have, if you need crop-based advisories, then you have to put one in every crop that you're growing. Your land could be 1 acre, 2 acre, or 5 acre. Till 4 to 5 acre, it's pretty fine. You can use the single device.
No, there is another issue, like maintenance. Like, suppose you install only 1 or 2 these things. So, see, my village is around 85 kilometers away from Delhi. Okay, suppose I get 2 these kind of towers installed, 2 stations installed in my area because of 2 crops. The land is hardly 2 hectares, but there are 2 crops into that, mango as well as one other guava. Okay, so will you be able to provide maintenance for that? Suppose something happens to this. That was my concern.
What do you do when something happens to your crop? If some animal does damage to your crops?
No, crop damaging is not possible for them because trees are very strong as of now. These are 30 years old. So they can't do much of damage to the crop. Only thing is that whenever I replace some plants, some old plants, then only I have to take care of that.
So you have to take care in a very similar way of this. The device is pretty
Okay.
robust in a way that it can sustain weather, but it cannot sustain if some animal or somebody wants to go and try to
Actually
destroy.
there are a lot of antelopes in my area, so that is a area of concern.
Yeah, so this is a very common problem. I will not deny this is a very common problem in India, but then the solution, we know the solution. The way we are protecting our field would be the way we protect our device, because ultimately this is going to help you, and then you have to make sure that this is the same thing which happens with tractor also. Somebody can come and just steal your entire tractor, so you have to take care of that.
Thank you so much. Thank you so much.
All right, so I'll move on to a couple of other things that I was telling you about.
Anand, I had just one question.
Yeah, please.
Discussion. Apart from the installation cost, do you have any kind of a maintenance also which happens, and what will be the percentage like?
Yeah, so the way it works, I think a very good question that you brought it up. So there is, of course, a subscription cost to it. And that's where we say that we have brought down the cost significantly low for any farmer, any horticulture farmer to afford this kind of system. Because if you look at precision agriculture, as I was also hearing the earlier discussion, it is not considered a viable. So it was not considered a viable solution. Sorry. Okay. But the one that we have and the one that is currently being developed is pretty viable. And one reason for us to bring down the cost so significantly down is that we don't really put any margin on these devices. We have a subscription model wherein you purchase the device, and then based upon what is your crop season, for how long you want to use, you just recharge it. So it's very similar to Tata Sky. So you buy Tata Sky, and then if you want to see TV, you recharge it. If you want to use Fasal, you recharge.
I got it.
Perfect.
I think that's quite wonderful. That's quite wonderful. Very good concept.
Thank you. All right, I'll move on to some other things that we help. So these are the core propositions of Fasal, the main solution that we provide. Apart from that, the kind of impact that we have created, as I was saying earlier, I think in one of the questions, someone did ask me, how we are measuring these impacts. So all the farmers are all, we have more than 10,000 acres, 20,000 acres as of today that is under Fasal, that we have deployed our solutions, and we have measured all these impacts, and these impacts are pretty much validated and been published by natural media as well. In terms of water saving, we have saved on an average 20 to 30%, up to 70% in few cases, which is very water sensitive crops. In terms of spray cost reduction, we have seen on an average 18 to 25% in terms of decrease in spray cost, to a maximum of 16% for certain crops. As you might be familiar with, grape and chili are some of the crops which requires a lot of maintenance and are being affected by a lot of disease and pest. Apart from that, a very significant achievement in terms of increasing the overall yield. Not just increasing the yield, but we have also seen that your crop harvest is prolonged. In certain cases, especially the farmers of Chhattisgarh and MP who were growing chili and tomato have seen that their harvest itself prolonged for at least a month. So, earlier they were able to harvest 2 or 3 times their chili crop or their tomato crop. With Fasal, they were able to harvest it 7, 8 times. That we feel a sort of big achievement, and these are the things that really motivates us to work further or innovate further in this. Apart from building this solution, innovating precision agriculture and bringing precision agriculture to masses in India, we also have a very deep responsibility of making this entire agriculture ecosystem sustainable. And towards that initiative, what we have launched is something called Fasal Water Credit. Now, what we really do is, of course, water is something which is available to a lot of us to go and just use it the way we want. But it is a very valuable commodity. We all understand it, and we are all facing or seeing problems of drought and certain other things when it comes to water. What we have launched is a way in which we can reward our farmers if they are actively saving water by mean of, so it does not mean that we tell them to don't use water. We tell them to optimally use, and by optimally using, if you are saving water, then we calculate how much water saving that you have done, and we return the subscription amount that we charge from them, we give it back to them and promote water credit. And while doing so, we have so far saved around 3 billion liters of water. And these are not just numbers, these are calculated figures that we have. So this is an initiative that we launched, and I think by end of this year, we'll be saving more than at least 50 billion liters of water. That's the goal that we have for this year.
Really impressive, Anand. Really impressive, because water scarcity and government is also working on that. A really impressive initiative. Thanks.
All right, thank you. So this is I have come to an end. This is pretty much all. I think a couple of more things that.
Just ask you something, Anand, if you're okay with that.
Sure, please go ahead.
I want to know, these are only your proprietary solutions, or these are the one which are available?
Sorry, I'm not able to hear you. There is some
I think
background.
there is a connection issue, so we are getting a lot of vibration from your side. The voice is not clear.
Okay, 1 minute.
You can type your question also. You can just type in the comment box.
Can you hear me now? Can you hear me?
Yes, it's better.
I can, yeah, much better.
Can you hear me? Yeah. So what I'm asking here is, these are all, because these solutions are already available in the market, right? I also have implemented it. I'm just to give me a background. I have spent 19 plus years in IT side, so I'm quite aware of these solutions. These are something like proprietary to you. You're just strategizing that. And what about the sensor devices? You are procuring from someone and then you are just giving it to farmers. How the model is about your business model?
Thank you, Message to bring that question. I think most of the things that we have built in-house.
That's really impressive. That's really impressive. I would like to meet you actually.
Definitely looking forward to it.
Yeah.
The reason, again, I'll tell you the story also. So when we started, as you might be also aware, that the precision agriculture was a sort of scary term.
Okay.
Because the moment somebody hears precision agriculture, they used to think about a big setup, lot of cost, this, that. I think that this was the first misconception that we removed, so that we make this this concept not just viable to India, but also in a way that it can be adopted really well. So the first thing that we did is we brought down the cost of this device significantly down, as I said, 1/4 of drip irrigation. The second thing that we did was we built a really good model in which it can be adopted, which was a subscription model where we try to cut down the upfront cost and then have a substantial small recurring revenue, which is pretty much, and then that also comes with pay as you go. So if you have a 3 months crop, why would you spend for the entire year?
That's really right. See, on similar lines, we were also thinking recently, because that's a really, I think your initiatives are really cool. Really cool. I appreciate these things. Yeah. Go ahead. Sorry, Anand.
All right, no problem. Couple of things, as we were seeing some of the discussions happened earlier. There is definitely a slow adoption of IoT and AI in agriculture, but it has been implemented and it has been practical. And the future that we see is, what we really have to do is, we don't have to just educate our farmers. We also have to educate ourselves, because we are still, I think, in terms of understanding the ecosystem and market, we are still lagging behind a decade. And I feel that we should educate ourselves that what is really happening in the world, and we should get out of academia and go look into the real world and see what is really happening. Apart from that, reducing learning curve, not just with us but with farmers, is something that will improve the adaptability of precision agriculture. Improving internet connectivity in rural areas is something I think Geo has, whatever they have done, they have built a really fantastic infrastructure in terms of rural connectivity. That has also led doors open to a lot of people to come and use technology and get smartphones, get connected to the rest of the world. affordability of the technology, as I mentioned, we have brought down the cost by 1/4 of drip irrigation. We want to bring it further down to, at least 1/10 if possible in a couple of years, and we are doing, continuously working on that front, on that roadmap. Apart from that, as we mature, as we have more deployments, we will have more data, and data becomes really the key factor in terms of improving our quality of not just data, but all the predictions and all the microclimatic forecasts that we do. Apart from that, I think on the similar line that we were discussing, this is the next generation of the hardware that we have built, because the one that you might have seen here in pictures, looks really complex. There is a rain gauge, wind speed, wind direction on the top, and then solar panel, and then there is a pole required, a lot of sensors coming out. But if you look at this is exactly the same device. This is exactly the same hardware, but it does not have any such things. So this is a new design that is cheaper than the earlier one, but it has everything compact. It hardly takes 5 minutes for anyone to deploy. It supports any connectivity that is available in your farm. And then, you can easily connect your farm automation systems, as we were discussing, drip irrigation systems. Or if you have a net house, poly house, then you can, automate your blower and your fogger with it. So, we are advancing. India is pretty much advancing a lot in terms of bringing technology to agriculture and farming. These are our happy customers. Some of our happy customers, I'm sorry, I could not put everyone's picture. So, this might be some subset of our customers that are using Fasal and being benefited. They are, they are using Fasal for more than 2.5 years now. So thank you all for giving me time to present here.
Anand, it was really nice, the way you are implementing. I really like the subscription feature, pay as you go and all these things. And did you have your contact details over your website? Because we are going to start something. I would like to invite you to, because I don't want to, reinvent the wheel. Instead of, I want to, partner with you or do something on that front in Odisha. So I would like to have, if you can share your details, it will be really good. So I would like to contact with you.
Definitely. I think the team has my detail, and you can reach out to them. They will provide you. Otherwise, we can connect on LinkedIn or somewhere, and
sure. I'll connect over LinkedIn, and we can catch up. I really like to, have a word with you. Thank you.
Definitely.
Thanks for this insightful session. I really enjoyed. Thank you.
Mr. Anand, may I ask a question?
Please, sir, go ahead.
At the beginning of the presentation, you said you work on the horticultural side, and then you said that I would explain why, as of now, it's on the horticultural side, not on the other side. So I'm not sure if you covered that in your presentation already. If you did, I'm sorry, I missed it.
No problem, Tapan. I think I might have missed it. So again, the reason for doing that is more of a business decision. And so, of course, when we were building this solution and where we have reached with the solution is somewhere where this solution is affordable or viable for a horticulture farmer. When it comes to farmers who are growing, let's say, grains or rice or paddy, for them, the solution might not be economical at this moment because of the cost economics itself. So of course, we want to go to those customers as well, but maybe the technology needs a little more evolvement in terms of those crops, as well as in terms of cost and other commercial viability. So to answer your question, yes, we want to reach there, but maybe with a different technology set that is more affordable to those farmers.
Okay. Is it okay if I ask a follow-up question? I just want to understand an insight here. Yeah. Now, the way I understand the grains and vegetables market is, they are mostly run by farmers who have small acre farms. And I'm speaking India-wise, yeah, whole of the country. Now, is it the same with horticulture, or is it run by, say, big-sized farms? Do you see what I'm saying?
I completely get what you're saying. I will say no, to this question. And okay, so the way I look at it is, if you have even 1 acre of land or 2 acre of land, and you are looking that land as a mean of progress and prosperity, then of course you'll try your best to achieve maximum out of it. If you're growing 2 acre, if you have 2 acre and you're growing rice, you know how much output you'll get. If you have 2 acres and you are growing chili, you know how much money you can make. So it's really, if you're looking at your land just by a mean of supporting yourself, then of course nothing can do wonder. But if you're really looking at your 2 acre land by a mean of prosperity and progress, then we'll try to optimize all the resources available to you and try to achieve maximum. So for us, or for to answer your question, no. There are horticulture farmers who grow fruits, vegetables, tomato, chilies, brinjals, who have 2 to 3 acres land, even less than 2 acres land, and they are also using Fasal. By the way, we have lot of customers like that who are 2.5 acres. They are using Fasal because they are growing good crops where the cost economics is very high.
Okay. Okay. Thank you so much for the answers and the presentation, Mr. Anand.
Ananda, I have a question.
Yes, please, Bharat.
Back to the slide where you had listed the impacts of Fasal, where you have mentioned there have been an increase and reduction in the spray and all these stuff. I just wanted to know, with the customization that you do for every different kind of a crop, are there any kind of recommendations which are also there? For example, as you said that you are a prediction company, and you, by various ways, are able to say that these are the kind of things which are going to affect the crop. So say, for example, I am doing fertigation with NPK and the other fellow is doing it with vermicompost. So how is there some kind of a recommendation about these kind of things also which are given by Fasal?
Not yet, Bharat. To answer your question, not yet. So here is what we do. When we measure something, and then when we recommend to farmer, we tell them about the problem that is going to happen and what are the solutions available. Now we left it to the farmer's good judgment to decide what suits best to his crop and his soil and his affordability. So we recommend, in terms of even sprays, we mostly recommend chemicals. We don't recommend a particular brand.
Okay.
In terms of, as you mentioned, in terms of, let's say, fertigation, we don't recommend what you should really put. What we tell ki, this is the condition of a farm and these are the things that you should do. You should, let's say, put more nitrogen. We don't say that you put this
brand. Okay.
This brand or that brand or vermicompost or whatsoever. We just tell them. Maybe some point later in time we will be reaching to a level where we can also say this, that for this for your current depending upon your current soil composites or whatever nutrients availability, you should take these things, or you should consider putting these things. Again, it is really very subjective to the practices that farmer has in terms of whether he's growing organic, whether he is not growing organic, or what exactly he is doing. So we don't exact provide the information in terms of brand and we provide composition but not the brand.
Okay, got it. Thank you. Thanks a lot.
Hello, am I audible?
Yes.
Yes, Ajay.
Are you working on only pre-harvesting side or post-harvest too?
That's a very good question. So right now only pre-harvest, Ajay.
Yeah. Are you planning any supply chain and logistics?
We are not planning a supply chain and logistics, but I would like to give you a sort of a future how we see Fasal providing or helping post-harvest and pre-harvest, preceding and post-harvest companies. So we are not going to get into logistics and supply chain, but we can be enabler or data provider for them. So a supply chain company can come to us and say they want to have a quality benchmark. Because these days everybody, food security is also becoming a major concern, and they want to know what farmer has done on their field, and what are the quality metrics, what was the weather conditions all around the entire crop season. So we will be able to provide certain, we will be able to enable them to understand from where they can procure, what they can procure, what will be the quality of produce, but we will not get into supply chain and logistics.
Can I know any startup working on processing, connecting the farmers with processing industries?
So there are a lot. There is Krishi Hub. There is Ninja Card. There is a bunch of such companies. So Krishi Hub is one. You can definitely go and check them out.
Okay, thank you.
Good evening, sir. I have a question.
Sure, please, Aranya, right? Yeah, please go ahead.
Firstly, thank you, sir, for such an interesting session. And your story is always inspiration that we look up to for building our for entrepreneurs like us. Firstly, my question is, as in case of any AI systems, in the very early days of your startup, when you don't have enough data, how do you ensure that your solutions are feasible and can be implemented? And following up with that, in the very early days when you are approaching your first or second customers, how do you convince them that your solutions are viable and they implement your solutions?
That's a very interesting question, Aranya. I think again, so this is how it really happens. How it really happens when we when we go and provide solution for a crop. So as you might be remembering that I told you that we are very crop specific. So what we really do is we spend a few seasons in that crop, collect data, and try to build our solution. And then we spend one season to collect data, one season to validate all the prediction models, and then we go to customers. So when we initially started, that time also, we spent close to an year in terms of just research. So for first year, I think around 8-10 months, we worked on grape and a couple of other vegetable crops, collected data, validated, collected data, validated. And once we were very sure, then we went to customer. And now this is the exactly same thing that is happening. So we have an agri research team who basically collects data for the new crops, builds solution, validates it. And once we are confident, then we go to customer.
Okay, thank you.
Mr. Anand, this is your LinkedIn page, like Fasal, grow more, grow better. Is it same?
Yeah, it is the same, Amit
Okay, thank you. Thank you.
Yeah, any other question from participants?
Yes, Mr. Anand, I have a question.
Please go ahead.
Yeah, so how did you start in the beginning? Like, did you go with a survey of farmers, or did you just introduce your idea and then took their views or their opinions, or you just developed first you developed the technology and then introduced your technology to the farmer?
Good question. Good question, Narpat. So the way we did was, we were trying to grow capsicum in Mysore, and then we figured out a lot of problems, as I mentioned earlier. And then what we really did was, when we started, we selected around 6-7 pilots in different crop of different age group of different, we did a lot of customer segmentation to identify different type of farmer persona, and then and different types of crops, and then we we went there. Once we had built the primary level of solution, we gave it to them, and then we took their feedback and we sort of lived with them for quite some time. And we took their constant feedback to iterate over what is our hypothesis and whether that is really what they need or they need something else. So as as a small sort of suggestion from me, if you're planning to build something, do a lot of research, go and sit with your customer, try to understand what he really needs. Don't build something in a closed door, because you might end up spending a lot of time and resource and money, and then it might not be acceptable to your end customers. So just try to understand, just try to go and live with them and spend some time with them, understand their core problems in detail. Then you will come up with a very precise, clear thoughts in terms of what exactly you need to build. So this is how we did it.
All right, sir. Thank you, sir.
If farmer is not able to understand the message, if illiterate, are you going for any different, like phone calls or like?
Very good question, Ajay. Again, so yes, so see, if a farmer can read, chalo good. But if a farmer cannot read, if he can listen also, then of course all the messages or all the recommendations that he'll get is probably on his phone call, in a language that he understands and in a way that he understands, not just language. So whatever way you understand how you have to irrigate your field, whether I say that go and put 5 liters per plant, खेत में 5 liter पानी डाल दो, or whatever language mean you understand, the message or the recommendations will get delivered to you. But of course, if you don't have a phone also, I'm really sorry. We cannot do anything.
Yeah. So any other question from participants? So Anand, I have a question for you. So when you say that, okay, you have this average 15% growth in the yield, so have you tried to trace back the sources, like from which part how much result is coming? Like you are doing some precision irrigation as well, and maybe you are having some weather condition monitoring because of which you are giving some feedback, and maybe you are having some pest monitoring. So there are different inputs that you're providing. So which one is giving how much benefit? Have you traced it back?
That's again a very interesting question, Professor. So we have traced back in terms of individual metrics. So for example, we know that how much water we have saved for that crop, for that customer in one season. We know that how much we have saved in terms of spray and pest or chemicals, and we know that final yield. Now what we see, when you have a good yield and higher yield, what we understand is because you have followed good practices, and that good practices is is probably the summation of everything. So it's proper irrigation, it's proper fertigation, and then it's proper management of disease and pests. Now it is very easy to understand where you would have so let's say if you have 20% higher yield, then of course how much irrigation you were doing earlier, or in what pattern, and then what was your disease and spray schedule, and how many diseases that would have happened, and then what could have been your fertigation schedule. Of course, we can trace back, but to answer your question, no, we have not individually traced back the yield with respect to different advisories that we provide. But we have sort of done, different advisories that we provide. We have tracked how much benefit the farmer has got.
Okay. Yeah. So maybe we can take a couple of more questions if participants have any questions, please.
Yes, Tapan again. Mr. Ananda, are you tracking the taste of fruits and how it, because you're not, did I get it right? If horticulture means fruits, yes?
Mm-hmm.
Okay, so
sorry,
are you?
I did not get your question.
I was, are you tracking the taste of fruits? See if the taste and quality of fruits is improving or changing.
Maybe he's asking whether it's the fruit is sweet or sour, whether it is tasting.
Taste and the nutrient content of the fruits.
No, Tapan, to answer your question, we don't do that. But as I told you, we don't go into post-harvest. What we trace or what we try to measure is, when I say quality, for me, the quality was really in terms of your final yield and its quality with respect to what you have really used on your farm, with respect to different fertilizers, irrigation, disease, and pest sprays. Now, to measure exact quality, I think there are already laboratories, and there are new startups. For example, you should definitely look at this startup that is called AgNext.
Yeah. So in fact, I can comment here. So I have been a co-founder of AgNext.
Perfect. So you already know everything then.
Yeah. So I can tell you that we have a spectroscopy device with the help of which we can basically trace the chemical composition of any food. So you can have a mouse-shaped device, a small device with the help of which you can get all the data regarding the chemical composition. So Professor P.K. Biswas also mentioned something about spectroscopy, if you remember, first session. So we have, in fact, in AgNext, we have commercialized those kind of solutions where using the NIR scan, you can get the chemical composition of different kinds of food material, like milk, food grains, fruits and vegetables also. So using that, you can also get the sugar content, how much sugar content the fruit is having. So although I'm a faculty at IIT Kharagpur, but also I have been associated with AgNext as co-founder earlier. Right now I have exited, but I have done most of the technology development earlier with AgNext.
Very good to hear that, Professor. AgNext is, I think we are closely in touch with them, so definitely very good work they are doing.
Yeah.
Is it okay if I ask?
About the farm security one. So in fact, currently I'm trying to work on a new startup which is going to deploy this farm security setup. So those of you who are interested, please feel free to contact me because there are a lot of questions regarding farm security. Yeah. So any other question for Mr. Anand?
Mr. Ananda, do you? I'm asking as a city boy. I have no idea if farmers do it, and I'm wondering if you could tell us. Sorry. Do horticultural farmers insure their crops? Is there an insurance industry
Oh, yeah.
for?
Yeah, I think they are the one who who ensures the crops most of the time. Yes, there is, and I think most of the insurance companies are again, these new age startups. Not just insurance companies, but various companies who provide credits as well, or microfinances as well. So yes, to answer your question, yes, there are a lot of companies who provide insurance, and there are a lot of farmers who actually insure their crop, and they are not a rice farmer; they are a horticulture farmer.
Okay, thank you.
Do you have a franchise model also?
Not yet. So we have a distribution model.
Okay.
I think.
And what are the distribution centers in North?
North, we have not yet started. We are primarily present in the southern part of India, and then like Madhya Pradesh and Chhattisgarh. I think by end of this year we will be present in North India as well. So, of course, we are present in Himachal for apple growers, but have not started full-fledged in North India so far. The target is this year.
And otherwise, you are based at Bangalore.
We, as a company, we are based out of Bangalore, but we are like, I think the team is in Maharashtra, MP, and other places as well.
Okay. Thank you. Thank you.
Yeah. So any other questions before we close?
May I ask one more? I'm sorry.
Let's wait for others because we have already had a lot of interactions. Let's see
Yes,
whether
I know.
others have any questions.
Okay.
Anybody else having any questions for Mr. Anand? Okay, so if nobody else has, then Mr. Tapan, we can have one more from you. Final.
Thank you. The way I understand it, pollination is very important for horticulture, and there are probably bee farmers who provide services for pollination because the populations of wild bees are probably not dependable. I was wondering, so I should probably ask an umbrella question here. Can you talk a bit about it with respect to if you're connected to it with bee farming, and if you do pollination services, or do you know what I'm asking? I'm not.
So Tapan, not really, not yet there. I think we are still we have a lot of problems to solve in especially the precision agriculture area where we are currently working. But I do understand the importance of that as well, and maybe someday we will be working on those solutions as well. But to answer your question, not as of now. I do know a couple of startups. I'm not sure any Indian startup does that, but definitely I know a couple of startups in the West who has done really have built very good solutions for pollination also.
Okay, thank you.
One more question, if you allow me. Do you have a plan to integrate your future developments with the existing customers at a reasonable cost?
You have to help me understand that question a little more.
No, like suppose you install a technology now, and you upgrade it at a later stage. So do you have any plan to extend this facility to your existing customers in future?
Yeah,
at some reduced cost, or at some costs which are really okay.
We do have, and to again answer your question, sir, if you look at the system that we have in terms of hardware is just a mechanism for us to provide data. Most of the real work is done via the algorithms that we have developed. So, and this is a continuous development. So today we develop algorithm for let's say for this disease, tomorrow we will have 10 more disease covered under that crop. Now that is available to you without any cost, because you're paying subscription, so you will be enjoying all those benefits. We have also developed inbuilt farm management and operation tracking software that is readily available to you free of cost. So we keep on adding features to our application. That is easily available to you, without any extra cost. When it comes to hardware, let's say if we build a new version of the hardware, then it's very similar to how we upgrade our phone and laptops. We have to upgrade the hardware also. But in terms of providing you all the features and new features, I think that comes without saying. And as soon as you have a new application released and new feature released, it will be immediately available to you.
Thank you, Mr. Anand. Wonderful session. It was quite enlightening. Thank you so much.
Thank you, everyone. Thank you for having me here.
Thank you, Mr. Anand. For a wonderful session, and we had a very nice interaction as well. A lot of exciting and relevant questions from the participants. And definitely, this is a topic which is having a great future in agriculture. You cleared a lot of apprehension and doubts regarding the practicality of IoT and AI solutions. You showed the demonstration how you have been able to bring about positive impact of these technologies and showcase positive results in India, especially for small farmers. So thanks a lot for your presentation. And those of you who are having more questions and want to interact with Mr. Anand, please feel free to send us your queries. We will be happy to share them with Mr. Anand. Otherwise, you can also visit their website and contact him directly through email. I hope that is fine, Mr. Anand.
Yes, yes, sir. Yes, sir. Definitely.
Okay. Thanks a lot, everyone, for joining, and special thanks to Mr. Anand. And we hope we can stay in touch, and you can keep enlightening our community through your talks and interactions. We also have definitely future sessions and hackathons coming up where we will need entrepreneurs and innovators to come forward for mentoring as well. So those who are interested in working in this area, we will seek your support for mentoring budding innovators as well. So we look forward to your support.
Looking forward, Professor. Looking forward to help you out or probably learn more from all of you. Thanks a lot. Bye-bye.
Thank you, everyone. So tomorrow we will join again at 5 p.m. and the details regarding the session will be emailed to you. So please join us tomorrow. We will be going through sessions related to biotechnology application in agriculture tomorrow, which is again a very important area. So we will be having a lecture by the head of department agriculture of IIT Kharagpur related to biotechnology application in agriculture. Followed by that, there is a very successful startup as well, Fab as well technologies, Fab as well life technologies, where the CEO will be coming up, Mr. Anand Raheja from Fasal Technologies. So he will be also dealing with his biotechnology solutions for agriculture that he has commercialized through his startup. So let us join tomorrow again for these sessions at 5 p.m. Thank you.
Hello, sir.
Yes.
Sir, if we want to contact with any faculty, do we get any support from faculty of IIT KGP?
Yes, you please apply in the hackathon that will be coming up. We will be definitely helping you with all the mentorship requirements.
So before, if you want, if you have idea, if we developed the idea before, if you want to contact them, do we get a chance?
You send me an email and we will discuss.
Okay, sir. Thank you.
So all the email that you will be sending to the ABIC event, I think whatever ID you are getting, the email invitations are coming through ABIC event ID. So if you reply to that, that will come to me. Or you can also reply email to my personal ID. I'm typing both the IDs. So this is my personal ID that I'm typing. And the other ID is the ABIC ID from which you have been getting the email, abic.event. So this is the EBIC event IDs. You look at the chat box, I have typed both my IDs, the personal Gmail ID as well as the EBIC ID from which you are getting the emails regarding the event. So you can mail me your queries over there. We'll try to address as soon as possible.
Okay, sir. Thank you.
Okay. Thank you, everyone.